760 millimeter of mercury. Assume the density of mercury rho as the 13,600 kg per meter cube, and average density of air at that particular location you can consider as 1.18 kg per meter cube. So based on that, you need to find out what will be the height of the building, and the temperature given here is 27 degrees Celsius. Okay, so I think this is based on the hydrostatic equation. You can very well simplify and try to find out the height of the building. H, it's a pretty straightforward question. So answer will be 100. Then there is no limit to the radius of the curvature of circulation of anticyclonic wind. True or false? This is false. As you know that anticyclonic wind, there is a maximum limit. So this will be a false. Then the next question is what are the characteristics of the Farrell sail? Okay, so some of you have answered this question, like whatever was there in the slide. Sinking air, much less rainfall, deserts are present. One thing extra you should have added, the altitude or the latitude angle for the where it is seen. Okay, the Farrell said. So some of you have not mentioned that, few of you have mentioned. So between 30 to 60 degrees. So that's why I have deducted 0.5 mark on this. Then the coldest region in the Earth's atmosphere is mesosphere. Okay, so this is already there in the slide. I think most of the questions are there in the slide. It's taken from the slides. Name 4 different weather station instruments and state what it measures. Okay, so there are several instruments we have already discussed. A few of them are like, for example, the student has mentioned anemometer, petrostatic tube, thermometer, rain gauge. Okay, so the corresponding applications are also mentioned here. So if you have mentioned, you will get 2 out of 2. The synoptic scale of atmospheric circulation can last for, this is the largest scale, after this there is another scale like planetary scale or global scale. So this can last for few days. Okay, so this can last for few days. Effect of the Coriolis force as you go high in the atmosphere, it increases. The Coriolis force increases because the velocity of the wind increases as you go high in the atmosphere. So that tends to increase the Coriolis force. Name the 4 factors that affect the temperature distribution in the atmosphere. So there are many factors. A few of them are mentioned here by the student. Solar radiation, compression and expansion of the air, eddy current of the air, then evaporation and condensation of the water vapor. Okay, so this is also there in the slide. Okay, so the next question is what is the maximum value of the gradient anticyclonic wind? Okay, so we have tried to find out the maximum condition. So it is 2 times the geostropic wind. Okay, this is already we have derived. In the wind spectrum analysis, what is the corresponding time averaging range of the spectral gap? Okay, so if you see that spectral plot of the wind energy density, you see that a region between 20 minutes to 2 hours, that corresponds to a flat region. Okay, so that flat region is generally referred as spectral gap. Okay, so this is the correct response, 20 minutes to 2 hours. The surface friction force. So sorry. Explain why the wind spirals near the ground and what is it otherwise called. Okay, so wind spirals because of the frictional force that you need to mention, and also you need to talk about the angle alpha that the wind makes with the isobars. Okay, where it is higher, where it is lower. So based on that, deflection can be visualized. Okay, so I think he has mentioned only the frictional force, but did not talk about the angle alpha. So I have deducted 1 mark. Otherwise, it is called as the Ekman spiral. Its other name is Ekman spiral. Okay. So that is one thing I was looking for here, as the angle with the isobars, how it varies with the height. Okay, so this question, I think only one student have answered it correctly. Other are, I don't know why they did go wrong so much. So you basically need to use Fisher-Tippett type probability distribution function of the wind. So this is the table, it is given to you, and from that you need to find out Gumbel variate, right? If you rearrange this in an increasing order, then try to find out the Gumbel variate, and from if you plot them, then you can do a best fit curve, and that will give you alpha and beta. Okay, so or 1 by alpha and beta from the plot itself you can get, and using those information you can find out what will be the maximum wind speed for this particular return period of 60 days. And the second question is you need to find out using that maximum wind speed what will be the risk factor. Basically in this case, instead of, the question is slightly twisted, so maximum wind speed happen in 60 years return period. What is our of interest for this particular question? So you can take T as 60 years and your exposure time as 80 years. From that you can find out what will be a risk factor. Okay, that is pretty straightforward, and I think the value is 0.739 or 74, whatever, like nearby this range I have considered, and he got half mark. The other half, actually, that is I think somehow you guys have did not do the plot properly, or because I see there are 2-3 variant of the numbers. Someone got 41, someone got 56, few of you got 38, 39. So the correct answer is 28 point something. So one student, if I remember, Hitesh, and someone else, probably Arsajit, or I don't remember, nearby this nearby value of 28 they got. So others, please try to see where did you go wrong. Okay, so this one is that. So 2.5 for one answer. So since he has corrected one question, so 2.5. The northern hemisphere, the cyclonic winds are in which direction? Okay, this is counterclockwise. Anticyclonic winds are clockwise. Okay, this is pretty general. Bottommost layer of the atmosphere is called troposphere. Yes, all of you know about this. In the stratosphere, air temperature reduces with an increase in height. True or false? This is false. In the stratosphere, for some region, temperature stays the same, but afterwards it reduces. Sorry, afterwards it increases. So this is false. Coriolis force reaches to its maximum at. Okay, so the force reaches to maximum at poles. Okay, its minimum value is at equator, maximum is at poles. Right. Then the next question is, what is the cyclostopic wind flow? Where is it observed? The cyclostopic wind is actually a special type of wind where the force balance between centrifugal force and the pressure gradient force occurs, and generally this is found, I mean, in the smaller curvature of the tornadoes. Okay, where your this force balance is possible. Okay, so cyclostopic wind is generally observed in the swells like tornadoes and the smaller radius, basically. Okay, so that's the response to this one. In one line, state the difference between weather and climate. Okay, so weather is a short-term description of the atmosphere for various states, like this guy has mentioned, temperature, rainfall, etc. So short-term description of the atmosphere, whereas the climate is a long-term time average description of the atmosphere at a particular location, or time average distribution of the weather in a particular location. Okay. Then the next question is, the wind which is initially at rest can be brought to a motion under the action of which force? Okay. So this is out of the four options, the gravity will be the correct answer. Okay. Because the remaining force will act when the wind is in motion. So when wind is stationary or the air is stationary, it can be brought to motion by the action of gravity. What is the risk factor for the exposure period of n equals to 50 years and return period of t equals to 90? Is a similar question like previously we have seen. So this the correct response is 0.4. Okay, under the effect of frictional force, the gradient wind gets deflected towards lower pressure area. I think this is the question which Moodle could not handle properly. So I need to re-evaluate for all of you, and some of you got one extra mark. Okay, so this will be low pressure area, low pressure region. Okay. In the wind spectrum analysis, explain the characteristics of the observed peaks. Okay, so there are few peaks. If you see the wind spectrum plot, so the we have identified a couple of peaks. So the 1 minute cycle, the peak corresponds to 1 minute cycle, is basically for the turbulence, small scale turbulence that you observe due to the industry or the surface roughness. So that's then half day cycle, that peaks corresponds to the day and night fluctuation of the wind due to the change of 12-hour wind condition. So because of that you get a half day cycle or 12 hours peak. Then the other one is 4-day cycle. These are some of the large scale pressure changes. If there is any change, unsteadiness happening over the large scale, so generally you tends to see 4-day cycle or around that figure. Okay, 4-day cycle. Yeah, so these are the three peaks we observed. Okay. Then the next question is, a pitot-static tube is used to measure the velocity of air flowing through the duct. The manometer shows the difference in the head of 5 centimeter of water. If the density of the air and water is this and this, determine the velocity of the air. Okay, assuming the coefficient of the pitot tube is this much. Okay, so this is pretty straightforward pitot-static tube measurement. Using the velocity equation, you can find out uh, the velocity of air in this case. The correct answer is 28.86. Okay, side to application of Stevenson's screen. Okay, so there are many applications. So few of you, I think most of you have answered it correctly. So it houses different instruments and produces an environment so that this instrument can work properly by avoiding higher amount of solar radiation or the humidity condition, precipitation. All those things can be avoided so that the devices can operate properly. And some cases, this, if you talk about dry bulb temperature or wet bulb temperature, it produces a suitable path for the wind so that the thermometers can measure this dry bulb and wet bulb temperature properly. Okay, so that is, there are many. So all of you, I think most of you have answered this correctly. Within the atmospheric boundary layer, wind crosses the isobar. Is it true or false? Yes, it's true. I think we have discussed this because wind spirals near the ground because the frictional effect. So it crosses the isobar. Yes. So I think these are the question. Any question from your end? Okay, give me a moment. Let me have some water first. Okay. So,
Sir,
yes.
sir, is it possible for next test that we get to see our own responses after you have checked it in Moodle?
Generally, I set that option, but I don't know why it is not showing. Uh, so, can you see your responses in the other tests? Any other professors?
In my last semester, there was a petroleum economics test. In that,
Okay.
as soon as like she used to give all the MCQ. Okay,
All
so
MCQs. Okay.
yeah, so
Hmm.
as soon as we finish the test, like after 1 hour, she'll allow us to see the response, and we could see that.
Hmm. Yeah, for so what I feel in my type of questioning, right? So here I have both subjective, objective. So probably because of that, this option is not working out, and that will work out maybe once all the I think questions are graded. Here I need to manually grade few questions, so that's why you could not see. Maybe, but I need to clarify with the module team at least for those questions which are auto graded. If you can see those responses. Okay,
Okay.
I actually give that option. I click that option on, but I don't know why it is not showing you guys. Okay,
Sir, it's available for combustion, which is a course we have this semester.
okay.
So our answers are available. Like how
Both,
much?
even if the question pattern is subjective and objective.
For subjective question, just the mark is given. I
Okay.
don't know if there's an option to write a comment there, but like the review that I have in
Acha,
that the
just the
marks are
mark
given.
is given. Okay.
Yeah,
Yeah, I can do that. Yes, there is
and
a. Mhm.
yeah, for objective ones, the correct answer and yeah.
Okay, okay. Yeah, let me try out in a proper way. I'll discuss with the module team and hopefully it will be sorted out. Okay. Yeah. Another thing. Any other question?
Hello,
Yes. Yes, Ajay.
hello,
Yes.
am I audible?
Yes, you are audible. Hello.
Hello, sir, am I audible?
Yes.
Okay, sir, I wanted to ask one doubt regarding one question. So you said that in the question it was written that Coriolis force changes with the altitude, and
Hmm.
what my understanding was that if I go along the latitude direction, then Coriolis will change. So like I wanted to ask why, what is the reason for Coriolis force to change as we go higher in altitude wise?
Okay. So if you see the Coriolis force formula, there are two things. One is your phi and one is your velocity. Okay. Altitude angle, and another one is your velocity of the wind. So when you are going from equator to pole, your basically phi is changing. Okay. Whereas if you are going higher in the atmosphere, your velocity, wind velocity is also changing. Okay, so in both the case, your Coriolis force will change, even if you move in the horizontal plane or in the vertical plane. All right.
Okay, but mainly Coriolis is due to the spinning of the Earth, and like if
It has a
we are
velocity
varying.
component also. If you
Oh,
see my lecture slide, probably the last table, there I have defined the Coriolis force value if I remember. Yeah, on the how the Coriolis force varies, it is there with the height. Okay. Okay. Any other question? Okay. So I will evaluate your MCQ 2 maybe this week sometime, and I will get back to you with the results. Then second thing is instead of Friday evening class, can we have it on the Saturday? Because now I don't have responsibility for the NCC. So my tenure with the NCC team is over. So if you all are available on Saturday, sometimes from 8 to 9 or 9 to 10, we can.
Sir, I have a test on Saturday. I don't remember exactly the time, but I need to check that once.
Okay. Otherwise, any
We have a
others?
test on Saturday, 6:30 to 8:30.
6:30 to 8:30 in the evening, right? I'm talking about the morning hours.
Okay, for morning it's fine.
Morning, let's keep it from,
Sir,
if you
morning I have
guys,
class from 10 to 12.
10 to 12. Okay. So 8:30 to 9:30, by assuming all of you can wake up by that time.
Yes, sir.
So let's have it from 8:30 to 9:30 on Saturday, because having two classes on Friday itself, like, it doesn't feel good also, morning and again evening. So we will shift the Friday evening class to Saturday. Those will be that's the extra class. Okay. Okay. So let's begin today's lecture. Okay, so today we will start with a new topic, wind energy or wind energy harvesting in particular. Okay, so which is different than the previous ones, but where we have just discussed about the wind in general. Now we will see different devices that you use to that you can use to harvest wind energy. Okay, so first thing, there are different energy sources, as you all are aware of it. There are few which are called non-renewable energy and few are renewable energy. Okay, so can someone tell me what is the basic definition in one line? Why we categorize these are renewable and why we categorize these are non-renewable energy? What is the difference between this?
So renewable energy are like it is unlimitedly provided to us, and
Okay.
non-renewable are limited or it takes very large amount of time to get renewed.
Okay. Any other response?
So renewable, if we can change them, we can use them again and again.
Okay, so the more appropriate response will be this energy source. Okay, in non-renewable energy, the energy source is exhaustible. Okay, it can get exhausted after a couple of years or maybe few hundred years. But in case of renewable energy, the energy source is inexhaustible. Okay, so it is not going to exhaust, at least during your life cycle. So it can last for pretty long. Okay, like for example, oil, coal, natural gas, and nuclear energy. These, when the energy source is exhausted, you will not have these energies anymore. Okay, whereas if you see solar, wind, wave and tidal, geothermal, biomass, hydropower or hydral. So these energies, these will be there forever, you can say, if you compare your life cycle. So since the energy source is inexhaustible, in this case, this will be called as renewable energy. Okay, so there are various renewable energy which already we have identified here. Solar energy, wind energy, and wave and tidal. Basically, they are in ocean related. Geothermal. Anyone know about geothermal? When we can tap out energy from the Earth's core. Okay, so if you know that Earth's core is very high temperature, and if you can somehow get that high temperature condition, basically steam also, so that can be used to run geothermal power plants. So this is coming up in various European countries. So where you can tap out the geothermal energy, and it's a big research area right now is going on. Then there are biomass, anything that you can burn, biological stuffs, like starting from wood and anything you name it. So if you can extract energy from that, so that will be a biomass energy. Then hydropower, like basically in this case you convert the potential energy of the water in the form of dam, uh, or we will not include the ocean tides because they are a separate category. So hydropower plants, so potential energy of the water, in this case you can convert to particular usable form like electrical energy or some other usable form. Okay, so that will be
Excuse me,
hydropower.
sir.
Yes.
So because of the high calorific value of nuclear energy, it is more or less considered as a renewable form of energy.
Many researchers, they put it in the renewable because the amount of material or the energy source available to us will not be exhausted so soon. Okay, so some of them they put it in the renewable source. So I mean, it is a kind of controversial thing, and the whichever way you are categorizing it, but ultimately in some sense it is going to be exhausted. Okay, so that's why I put it better, try to put it here. Okay.
Right.
Any question? Okay, so let's move on to the next one. So wind energy is basically a form of solar energy. As you can see, the source of wind formation is ultimately because of the sun itself. If there was no sun, it is not possible to have the wind. You can see that because of the solar energy or solar radiation received by the atmosphere and the earth surface, those are uneven. Okay, and like during the daytime and during the night time, because of that unevenness and irregularities on the earth surface and rotation of the earth. Okay, these are the factors which already we have identified in the chapter 1 that produces the wind. Okay, so wind energy is actually a form of solar energy, but it is not the 100% solar energy that we are talking about because it's a modified form of the solar energy, you can say. So these are the factors which creates the wind, and on the earth surface the wind condition gets modified also, we have seen, because of the terrain condition, presence of the water body and vegetative cover, the surface toughness and the presence of the water bodies. Like you know that the temperature absorption by the inland and the water bodies, they are quite different, and also the during the presence of the solar radiation and absence of the solar radiation, the temperature change will be also significant in both of the inland and the water body case. So due to the temperature gradient, basically we saw that there will be change in the density of the air, and because of that there will be circulation. Okay, so there are different type of natural circulations you can what we have observed previously. So that basically happens because of the this presence of the water body, terrain condition, and vegetative cover. Now, so the wind flow, as you can see, it has kinetic energy in it. Okay, because wind is flowing, so the most amount of energy what it has is on its motion, or it's kinetic energy. If you can tap out that energy using some devices, then that can be used for various applications. Okay, for example, generation of the electricity, or water pumping, or in case of grinding of grains, there can be various other application where you can basically tap out the motion of the wind through some devices and carry out this application. So basically these devices are called wind turbines. They are also called windmills. We will see how these devices can be differentiated based on their application. Okay, what is their final application? Based on that you can differentiate these devices. Okay, so here two main concerns that we will try to see in this particular chapter. How much energy is available in the wind when you're talking about the renewable source of energy, and particularly focusing on the wind. So why it is so interesting, not going to for this particular course. Yes, we are just focusing about the wind energy itself, but there are other renewable energy. So how much energy content is there in the wind, that is what we will also see. Then the second part will be how we can extract the useful amount of energy, or the which is called wind power using wind turbine technology. Okay, so these two will be our two major discussions in this particular chapter. Okay. Now, before we go to the details, let's see how much the wind energy is being extracted currently or harvested by different various countries throughout the world. This data is as of 2017 data. I did not get the updated one. So then we can see that China, it has its 34% of energy which is being extracted from the wind. USA around 18% of its whole energy consumption, and this one in India around 6% during this year. Okay, 2017. Now this figure will be a little bit on the higher side, maybe 9% or so. Okay, so this is the energy chart, like the amount of energy extracted by wind energy extracted by different countries in the world. Okay. Now, yes,
Sir,
any question?
sir, like China using the wind power, is it because they have more technology, or due to their like
Yeah,
location or terrain?
so yes, there are various reasons behind it. Of course, the technology wise, they are quite advanced. You can see that they are working in almost every areas. So that is one of the factor. You can say they have identified the problem first, and they are trying to solve them because their energy consumption is quite large. If you compare globally, China is one of the major energy consuming country. So so they thought like soon they need to go for renewable energy source, so they started early. That's why they are in this number. Additionally, the wind condition also is favorable to them. If you can see here, they have also a quite large coastline. Okay, so that I don't have the wind condition or wind data for China here. So that could be another factor. The wind environment available in the country, that they could able to tap out more, both technology as well as the environment. So when we talk about India here, this is the wind map on an average yearly basis. So you can see that India receives also a significant amount of wind on its western or southwest part in the coastal region. Okay, so you can see a lot of installation of the wind power plant are basically in this region like Tamil Nadu, Maharashtra, Gujarat. In this region, you can see there are a lot of amount of wind turbines are installed, or wind power plants are being installed in this location. Okay,
Sir, I
and
have a question.
yes,
Sir, how so if we see this wind profile, we can see that the winds are faster on the leeward side of the mountains, especially on the western coast.
mm-hmm.
How is that happening? Considering there is no obstruction on the left, the wind is coming directly from Arabian Sea. So how is the wind faster or the wind speed more on the leeward side of the mountains?
You mean on this region, is it? On the east?
On the west coast, let's say near Maharashtra, Kerala,
Acha.
where you go,
Okay.
you can see like this
Yeah,
distribution.
pretty much. So maybe this when they talk about this averaging thing, one of the thing is whether they have included cyclone or those which are typically observed in this region. With if that has accounted to get the average wind data, higher values here. Second thing is. Um, if you remember that shield effect, when we have a hill area, and after that, um, if you have a kind of valley region, okay, so there wind tends to also get enhanced. Okay, in a larger, if we observe this terrain condition, I don't know, like in detail, we need to see whether there are a lot of valleys or what kind of terrain condition is there, which might be promoting the wind speed. Okay, even if it is on the leeward side, but if the terrain condition is favoring to enhance the wind condition, that might be the reason behind a higher wind speed seen here. Okay.
Yeah, so
So
actually,
you need.
because when we read about monsoon, it says that the wind rises up, slows down, and which is why we get, let's say, for example, higher rainfall in Mumbai and lower rainfall in Pune, something of this sort. So I mean, this looks a little counterintuitive. That's why I asked.
Yes. Okay. Yeah. So yeah, maybe further you can investigate the geographical or terrain condition in general if you want to find out why this is so on higher side. Okay, anyway, so this is data I got from the Wikipedia. So whatever data we can see here, and there are supporting to this data, we see a lot of installation in this particular region, Maharashtra, Gujarat, Tamil Nadu, because of such higher wind patterns. Okay. So one thing is, later on we will see wherever we have the higher wind speed, the amount of energy that we can extract will be larger. Like I think one or two groups, they have already talked about this. Wind energy is like 3 times or cube of wind speed. Okay, proportional to cube of the wind speed condition. So higher the wind speed, you have higher amount of wind energy. Okay, that we will see subsequently also. So yeah, these are the total distribution of the energy. Again, this is in the year of 2016. You can see that Tamil Nadu has 27% of installation, Gujarat, then Rajasthan also. Okay, so Maharashtra also has 17% stands here. Okay, so these numbers are on a higher side now. Like in 2018, already we have crossed 35,000 megawatt wind energy production. So see, this is already increasing. Okay, and I think over the years, this is what how our installation, wind power plant installation in India is moving on. Starting from 2006, where we have less than 10,000 megawatt energy. Now somewhere we are in around 39,000 megawatt energy extracted from the wind itself. Okay, so we need to reach this number by 2022. I think this was the targeted. Hopefully we are close or near to this. Okay, now giving you some brief about the historical background of the wind turbine. This wind energy, or extracting the energy from the wind, this concept is not new. It is there pretty long. Like I think Chinese and Persian people, they started it very early, around 500 AD or so. So the idea is like wind turbines are basically devices which convert the kinetic energy of the wind into mechanical energy. Okay, any form of the mechanical energy. Then such devices will be called as your wind turbine. Okay, what is the opposite thing? If you use kinetic energy or mechanical energy to kinetic energy, I think that will not be very useful here.
That's like a fan.
Fan, yes. That I think that example would have come here in the second one, where we have mechanical energy is used to produce electricity. Then that will be a wind generator. If you are using electricity to produce mechanical energy, then that will be a fan, like correctly said. Um, so yes, so if you are using mechanical energy to produce electricity, then that will be a wind generator or wind charger. Okay. Then if the mechanical energy is used to drive some machineries, okay, then in that case it will be called as windmill or wind pump. So generally in the windmill, they are used for grinding grains, okay, or pumping water. So either ways it will be called as windmill or wind pump. Okay, so yeah, already I have said the idea is not new. It is there for years. The very first one was used by Chinese and Persian. I think the similar time they have evolved uh, with this concept. So they have used this vertical type of wind turbine or vertical axis windmill in particular, in particular way you can say. So here you can see the blades or sails are in vertical manner, and they are attached to a shaft here at the center. Okay, and these will rotate based on the wind condition. Okay, so if the wind passes through this passage here, so this whole thing will starts to rotate. Okay, and at the bottom you have several devices like maybe the grinding stones. Based on that you can grind grains, or it can be used for milling purposes. Okay, so that can be obtained from this housing below. So these were the very first wind energy system. Then afterwards, if we can straight away come to the Middle Age. So in European countries, they starts to have this horizontal axis type wind turbine. So here, when we talk about vertical and horizontal axis, it should be clear, like if the axis of the rotation is perpendicular to the incoming wind direction. Okay. So in this case, in the vertical axis, it is perpendicular to incoming wind direction. Then that will be called as vertical axis. And if your axis of rotation is parallel to the wind direction, then that will be called as horizontal axis. Okay. So here you can see around Middle Age, European countries, they starts to have horizontal axis wind turbine, and they are basically used for again water pumping purposes, not electricity, not for the electricity production. Then mostly for the pumping purpose. Okay. Yeah. So here one thing is you need to change the rotation using some gear technique. Like your plane of rotation is in horizontal manner, but your device may be in vertically lying somewhere here. So you need to have many gear axle arrangement that translate this horizontal rotation to a vertical rotation. Okay. So that is easier in this vertical type of windmill, where you have directly a vertical type of rotation, but in horizontal case you need to have several other gear arrangement where you can transfer horizontal rotation to a vertical rotation. Okay, there are few more like early 90s or 19th centuries. That time in rural America, there they have used windrows. Okay, so here you can see this is horizontal axis type wind turbine, but you have several many blades here. Okay, so it forms like a rose type of pattern. That's why it is called windrows, which is again used for the water pumping. Okay. So different from the previous one where you saw there are only 3 or 4 blades, so which is called horizontal axis windmill. In this case you have many blades. Okay, sometimes it can go up to hundreds also, like the next one you will see. So that it is used for the water pumping purpose in 19th century, early 19th century. So during that time, 1888, Charles Bruce, he built the very first wind electricity generation turbine. Okay, and you can see here the images there. Later on, it is associated with GE also. So it is 17-meter diameter, this whole thing. There are 144 blades. You can see there are many blades, and it could generate around 12 kilowatt that time. Okay, so it was pretty interesting result, but the device is huge and you need to have a huge tower here also. Okay, so later on, when we starts to use this fossil fuel and all, so that time the concept of this wind energy extraction, those were reduced. Okay, so whatever research was going on in early 19th century, um, so those researches were down because of the fossil fuel consumption during World War I and II. Afterwards, when we start to see that there might be a scarcity of the energy or this non-renewable energy source, so we are seeing again towards this wind energy and harvesting wind or any other form of the solar energy. So in 1920 or 1950s, and till today also we are seeing the propeller type 2-blade or 3-blade horizontal axis. There could be 1 blade also, we will see. So these bladed type of horizontal axis wind turbines are now also evolving. Okay, so this is how the wind turbines has evolved over the years. Okay, so there are types of windmills. Before we go to the wind turbine application, let's see the 2 different type of windmills, like we have already discussed: horizontal axis and vertical axis windmills. So windmills are those devices which are used for conversion of running the machineries. Okay, so that is what the basic definition we have seen. If the mechanical energy from the wind is used to drive some machineries, then that will be called as windmill or wind pumps. Okay, so here these are the horizontal axis and vertical axis windmills. Generally, you can see. So the basic difference is, like I have said, the axis of rotation. In one case it is parallel to the wind direction, in the other case it is in the vertical axis it will be perpendicular to the wind direction. Generally in the horizontal axis wind turbine, the tower is tall. Okay, you have a pretty big tower, and blades, they are used to capture the wind energy through rotation. Okay, so once they rotate, they capture the wind energy here. So basically you see that the blades are not straight, they are slightly curved. Okay, so here actually you can see that I have drawn 2 vectors. So one is for the wind force direction, the other one is its reactive force. Based on that, the rotation will happen. Okay, so because these blades are curved, when the wind flows through that curved surface, because of the reactive force, the blade will start to rotate in opposite direction. Okay, so one of the requirement of this windmill is you need to face the wind. Incoming wind direction, you need to face the wind. Like you can see that there are 2 windmills here. So they are facing the wind direction. Okay, so you need to have an additional turntable kind of attachment which you need to rotate and face the wind suitably. Okay, so that is one of the disadvantage, you can say. You need to turn the wind, turn the whole thing to face the wind, and it is a bit complex during the construction because you need to have a tall tower and other like I've said, you need to change the rotation, like from horizontal plane to the vertical plane. If you want to change, that's what the gear arrangements are necessary. Strong and huge tower is required because you're trying to tap the higher wind speed in this case. So you need to go high. Strong and huge tower is necessary. One thing is the principle of operation in this case is your push by the wind or thrust by the wind. Okay, so wind is pushing the blade in that is the principle of operation. All right. Okay, so okay, we still got 2 minutes. There is another going to the second type, the vertical axis wind turbine. So the oldest one is Savonious Rotor, and this is pretty simple to design. You can design using a drum. Okay, so you can see here, if you cut the drum into 2 halves and place them in this manner, slightly offset manner, and what will happen when the wind blows, it will start to rotate. Okay, you can see that this is concave and this is your convex surface. Because of the this configuration itself, the amount of the pressure distribution will be different in both the surfaces. Because of that, this whole thing starts to rotate. Okay, so again, this is based on the push or the thrust of the wind. There are few modifications done to Savonious Rotor to improve its performance. Instead of attaching the blades at this location, what they are doing, you have a shaft here and slightly align your blade inwards. Okay, like shown here. So in this case, what will happen? Some amount of the wind will pass through this gap and onto the top of this convex upper surface blade. Okay, so here since you have a high speed, again the pressure will be reduced more. So because of that, the performance will be improved. Okay, so this is the modification to improve the performance of the Savonious rotor. Okay, there used to have gyro wires so that you can mount this device or hold this device properly, because it is rotating and having only one vertical shaft. So you need to have extra gyro wires so that you can hold them at a place properly. Okay, so this is the overall construction of your Savonious rotor, which is your vertical axis windmill. The very beginning or the basic ones is used. Nowadays also these are used in villages. So they are used again for basically water pumping purposes. Disadvantage that they are low efficiency. Efficiency is quite low. You can see that they are pretty close to the ground where wind velocity is small. So efficiency is very low. May need to have additional wires to support, and more turbulent flow condition near the ground. Okay, so these are some of the disadvantages associated with the vertical axis or Savonious rotor windmills in general. Okay, so I think I stop here today. We will continue tomorrow.
Sir,
Yes.
I just had a question
Yes.
in which you had mentioned that in the horizontal axis, when like turbine, what do we change? Do we change the angle of the